In this video, I'm going to go over how to answer the following question where you're given a piecewise function with either 2 or 3 different graphs with different domains. And typically, there are 2 open circles and then 2 closed circles. So this function is discontinuous and it's asking you for the true statement. And this question can actually be really tricky unless you have a way to visualize it. So I highly recommend that you draw a graph for this question and graph both of the piecewise functions. So my graph can look something like this. It doesn't have to be perfect. As long as you have like a rough sketch, it should do. Maybe I want to move it down a little bit. Move this down too. And make the y-axis a bit bigger. Okay, so what I'm going to do, I'm just going to plot all the x values that are given in our domain for now. So x equals -1 could go here. X equals 2 might be good over here. Then x equals 5 might be good over there. And then here is just 0. And so we want to see what happens to each of these functions when they're equal to those x values. So for the first function, x squared plus 1, when x is equal to -1, that will be -1 squared plus 1, which is just 2. So we can plot 2 on here. And it'll be a closed circle because the function is actually defined there. What about when x is equal to 0? When x is equal to 0, the y value is just equal to 1. But what about when it's equal to 2? Well, according to the domain of the piecewise function, x squared plus 1 is not defined at 2, so the function never actually touches 2. However, for our purposes, we'll just plug it in anyway and see what happens. So 2 squared plus 1 would be 4 plus 1, which is 5. So we could go all the way up here. And then we're just going to draw an open circle because the function is not actually defined at x equals 2. And so then we can sketch the curve. And like, it doesn't have to be perfect. As long as you kind of get the rough sketch, it should be okay. Okay, so we got the first part done. Now, what about the second function, which is -x minus 3 squared plus 4? So what happens when x is equal to 2 for that function? So when x is equal to 2, the function is equal to 3, because if we do minus 2 minus 3 squared plus 4, that is 3. So we can plot 3 here. I'm going to use a different color, maybe the green. We'll put a closed circle because it's actually defined there. What about when x is equal to 5? Again, the function is not actually defined at 5 for that piece specifically, but for our purposes, we'll plug it in anyway, and we'll just draw an open circle. So when x is equal to 5, the y value is just equal to 0. And so we'll just draw an open circle here. And it looks like we're kind of missing a piece. I feel like because this is a quadratic, it should go something like this. So perhaps there is another x value we could add here. Another x value you could add could be like 3. And when x is equal to 3 for this function, the y value would be at 4. And so we can just plot the point. Again, it doesn't have to be completely accurate, but Okay, so we're done the graph now. Now we can actually verify these statements. So statement A says that f has both an absolute maximum and an absolute minimum. Well, let's look at this graph. We see that technically, like, this would have been a maximum point, this would have been a minimum point. However, because we have open circles here, you cannot say that those are absolutes anymore. So statement A is false. And then statement B says f has no absolute maximum and no absolute minimum. Well, based on what I just said for A, option B would definitely be true. So this is the true one. And then if you read option C and D, those won't make sense either. Those are going to be false. And so therefore, B is your correct answer.